Hello students, welcome to engineering geology classes. So we will start with the dip and strike concept. So dip of a rock is the angle of inclination of a bed with respect to the horizontal plane. So dip and strike is also called as the attitude of beds. So here you can see the rocks are dipping, and this dip is defined as the angle of inclination of this bed with respect to the horizontal plane. Okay, this light color you can see, that is a horizontal plane, and the angle between the bedding plane and the horizontal plane is called as the dip. And the strike is defined as the direction of the line. Okay, this line you can see, the direction of this line which is formed by the intersection of the bedding plane and the horizontal plane. So they are intersecting along this plane, so that is called as the strike, or you can say the trend of the rock. Okay, the rocks are dipping like this, so that is the trend of the rock. In this direction the beds are dipping. So dip and strike is very important concept to understand the further concept, that is folds, faults. Okay, so in today's class we will start with the folds. In today's class, we will discuss the different geological structures. So, what is a geological structure? So, any geological structure is any feature which is produced by the rock deformation. So, we have seen the different types of deformation, stress, strain, right? So, the feature which is produced by the deformation of the rocks, that is called as the geological structure. So the tectonic forces, they create the three types of main geological structures, that is folds, faults and joints. So these are the three structures which are formed because of the tectonic forces acting on the rock. So the first one is the fault. So in the image you can see faulting. Okay, so here you can see this bed, you can concentrate, there is a black colored bed. Okay, then same bed where you can trace is here, right? Then you can just see there is a line here, right? So that is nothing but the fault. So what is a fault? This bed was here earlier, but because of the faulting it has moved down, or this has moved up. Okay, so that is called as the fault. The displacement of the beds along the fault plane, that is, or fault line, that fault plane, okay, that is called as the faulting. So wherein the displacement of the beds takes place. So the beds are displaced from the original place. So this is because of the tectonic forces acting on the rock. So fault is what? The displacement of the beds, okay, along the fault plane, that is called as the fault. Okay, then the next feature you can see, that is a joint. Okay, joint is what? Joints are, you can see there are cracks which are hexagonal in shape. Okay, these are the cracks which are formed as the magma cools down. This we had seen when we were talking about the columnar structure in the basaltic rocks, right? So here same way the joints are produced, that is commonly seen in the basalts. So here how these joints are formed? Again, when the magma starts cooling, okay, due to tectonic activities the magma is coming out, and while cooling it develops the centers of contraction, and the magma or the lava starts cooling towards that center point, you can see. So because of that, the cracks are formed here while cooling the lava. So these structures are called as joints. So there are different types of joints again. Okay, this is one type of joint, that is a columnar joint. So in general, what is a joint? Joints are the cracks. Okay, joints are the cracks which are developed in the rock. So they control the groundwater percolation. They are very, very important. Even they support the weathering also, right? So they play a very important role in case of civil engineering. Okay, then the next is unconformity. This unconformity is not formed by the tectonic process. This is formed by the depositional process. So how it forms? You can see that these rocks, they are inclined like this, okay, and this is a horizontal beds. So on the top there are horizontal beds, and at the bottom there are different rocks which are inclined. So how it happens is, this type of structure is called as the unconformity. Okay, so this is called as the unconformity. So how it forms is, first these beds have formed, then they have undergone some tectonic processes and they have become inclined. Then after formation of these beds, there was a gap in the deposition, or there was no deposition, and later these beds have deposited, the horizontal beds have deposited one above the other. So you can see there is a gap in the deposition of the beds. So this structure is called as the unconformity. This is the line of unconformity which is shown in a zigzag way on the map. So here unconformity means what? This is a gap, okay, or a gap between the two different types of deposits or rocks, or it is a time interval, okay, which separates the older formations and the younger formations. So it is the line which separates the older formations and younger formations. So that is called as an unconformity. Then one more feature is fold. So fold is what? The undulations which are developed in the rock. In the image you can see this rocks are being folded like this. Okay, you can clearly see the folded structure, right? So this is called as the fold. So what is a fold? Fold is formed due to compressional forces, right? We had seen in the previous class, right? So here the stress which is acting on the rock, that is the compressional stress, and because of that the rocks gets folded. So folds are, how you will define fold? The undulations, the wavy undulations developed in the rock, they are called as the folds. So these are the different structures which we are going to discuss in detail. Okay, so in today's class we will start about the folds. So folds, this is formed because of the tectonic process. So folds may be defined as the undulations or the bends that are developed in the rocks of the earth's crust. So what is the reason for that? The stress to which the rocks have been subjected to from time to time in the past history of the earth. So this is not a continuous process or quick process, you can say, right? It takes many years, okay, millions of years to form such type of folded or faulted structures. So here the folds, they are the bends, okay, these bends are called as the folds and they may develop in any type of rock. Okay, it may be igneous, sedimentary or metamorphic rocks. They show the folded structure, but they are best displayed in the stratified rocks. So stratified rocks are nothing but the sedimentary rocks which are formed layer by layer. Okay, so even the volcanic rocks, they are formed by layer lava flows, right? So those rocks, they exhibit in a better way. So and the metamorphic equivalent of those sedimentary and volcanic rocks. So what is a fold? You can see here there was a horizontal strata, okay, and this strata was subjected to compressional forces, and because of that forces acting on the rocks started bending. So that bends, okay, that is called as the fold. So what is a fold? The undulations or the bends that are developed in the rocks of the earth's crust as a result of stresses to which the rock is subjected to from time to time in the past history of the earth. So that is called as the folds. Now let us discuss the different parts of fold. So these folds, they may be of different shapes and different size. Okay, laterally they may extend for several kilometers. Okay, and there are folds which are hardly few meters or even few centimeters. They are very small to very big folds are present on the earth. So the the extent of folding that is undergone by the rock and their ultimate folded shape, that depends upon what? The magnitude of the stresses which are acting, the intensity, the type and the duration of the stresses which are acting on the rock. Okay, so that decides the fold. So let us discuss the different parts of a fold, or it is also called as the fold terminology. So the here is in the figure you can see there is a fold. Okay, this is a fold, okay, folded rock. Then there is a plane, okay, which is called as the axial plane. You can see this plane is the axial plane, and how it is, what it does, it divides the fold into two equal halves. So it is defined as the imaginary plane. Remember the axial plane, the definition of axial plane is what? It is the plane, it is an imaginary plane which divides the fold into two equal halves as symmetrically as possible. So that plane which is imaginary plane, that is called as an axial plane. So axial plane, it may be vertical or it may be inclined or it may be horizontal also, depending on the fold, the type of fold. Then so this is the axial plane. So what is axial plane? It is an imaginary plane which divides the fold into two equal halves as symmetrically as possible. So that is a axial plane. Next part of the fold is this, the limbs of the fold. Okay, so what is a limb? Limb is the sides of the fold. They are called as the limbs, or they are also called as the flanks. Limbs or the flanks. Okay, they are also called as flanks. So what is a limb? Limb of the fold, that is the sides of the fold. Okay, sides of the fold, you can see this is the side of the fold, this is the side of the fold. Okay, so this part is called as the limb of the fold. Okay, so this limb limb extends from one axial plane in one fold to the axial plane in the next, and that is what, suppose there is a series of fold like this, then this one limb will be shared by the two folds, right? So this is common for this fold also and this fold also, so that is called as the limb. So a limb, it will extend from the axial plane of, here this is the axial plane which divides the fold into two equal halves. So a limb in a fold, that in one fold, that is it extends from the axial plane in one fold to the axial plane in the next fold, okay? And an individual fold, it will have the two limbs. Suppose the fold is individual like this, okay, then it will have only two limbs, whereas in the series of fold, what will happen, the central limb that is shared by the two, or the it is common to the two adjacent folds, so that is the limb of the fold. So what is limb? Limb is the side of the fold or flanks of the fold. Next part is the axis or the hinge of the fold, okay? Fold axis, or it is the hinge of the fold. So here this is the fold axis, you can see. So how you will define that fold axis? The line of maximum curvature. So here this is curved, and here is the line of maximum curvature in a fold. So hinge or the axis of the fold is, that is the also called as hinge or fold axis. So how you will define? The line of maximum curvature in a folded rock, that is called as the hinge. So it is the line of intersection of the axial plane with any bed of the fold, so that is called as the axial or fold axis, okay? Fold axis or hinge. Then one more part of the fold is, suppose there is a series of fold like this, okay? Then this becomes the okay, this is a series of fold. Then this line, it becomes the axial plane which divides the fold into two equal halves. So here in such folds, this portion, okay, and this portion, that is the crest and trough of the fold. Like in wave we have studied, right? There will be crest and trough for the wave also. So this is again wavy undulation, so there is a crest and trough of the fold. So how you will define the crest and trough of the fold? Suppose the line, okay, line running through the highest point in the up arched fold, that defines the crest, okay, and suppose this is the up arched fold, then the line which is joining all the up arched fold, that is called as the crestal plane, okay, crestal plane. This is the crest, not crust, okay, it is crest of the fold, okay. So there are two type, up fold and down fold. So in an up folded rock, okay, the line running through the highest point in an up arched fold, that defines the crest, and the corresponding line which is running through the lowest point on the same bed in the down arched fold, this is the down arched fold, so that is called as the trough of the fold. So the plane of the surface which is formed by all the crust, that is called as crestal plane, and the line which is formed by all the troughs is called as the trough plane. So the crest and trough of the fold. Next, the last part is the plunge of the fold. Okay, plunge. So plunge means what? Here you can see plunging fold. So what is that plunge? So here you can see the fold axis is like this. Okay, and here the fold axis is inclined. You can see the difference between the two figures, right? So the fold which have the inclined axis, that is called as the plunging fold. The fold which has inclined fold axis, that is called as the plunging fold, and the angle of inclination of a fold axis with the horizontal, that is called as the angle of plunge. So here this is the angle of plunge. What is that? The angle between the fold axis in a plunged fold, okay, plunging fold, and the horizontal plane. So angle between horizontal plane and the fold axis, the inclination of a fold axis with the horizontal plane, that is called as the plunge angle or angle of plunge. So these are the different parts of the fold, which is again very important question from exam point of view. So here limbs, fold axis, axial plane, then plunging fold, crest and trough. So these are the different parts of the fold. Now let us discuss the different types of fold. So here also you can see how it looks in the ground. Okay, so there is a fold here. Okay, the rocks are folded, you can see, and here this is the dip of the beds, this is the strike. Okay, in the hill it is exposed like this. Okay, so strike and dip of the fold. Yes, then here you can see the crustal plane, trough plane and crustal plane. So here in this video you can see how the rocks get folded. So there was a deposition of the beds. Okay, then the beds which are deposited, because of the compressional forces which are acting on the rock is getting folded. You can see the rock is getting folded. So these are some field examples, okay, wherein you can see there are folded rocks. So here you can see the rocks are folded here. Okay, here also you can see the folded rocks. Okay, then we'll discuss the different types of folds, which is again a very important question from exam point of view. The different types of folds or classification of fold. So the first classification is based on the nature of bending, how the rocks have bent. So the first is anticline fold. Anticline, the word anti is opposite and cline is inclined. So the anticline fold may be defined as the fold that is convex upward. The fold that is convex upward. So this when the beds are upfolded into an arc-like structure, then it is called as an anticline fold. So in such folds, the bends or the limbs on either side of the fold, they dip away from the axial plane or the crest. So this is the axial plane, okay, which divides the fold into two equal halves, and the two limbs, they are dipping away from each other. Okay, so the word anticline is from a Greek word meaning opposite inclined. Okay, so in anticline fold, if you see, this is the older bed and this is the younger bed. So older bed, that occupy the center or interior of the fold. So at the center you will find older bed and younger bed will be at the top. So this is an anticline fold. Then next type, yes, here you can see the examples for anticline fold. Here you can see the rocks are folded like this. Okay, you can see the different beds or the layers, they are folded in an up arc like fold, that is an anticline fold. Here again you can see a big hillock which is folded. Okay, folded rocks you can see like this, the rocks are bent, so that is again an anticline fold. Then next type of fold is a syncline fold. So syncline, so syn means towards each other, okay, towards incline. So syncline is defined as the fold that is convex upward, okay, or sorry, convex downward or concave upward. So the fold that is convex downward, that is called as an syncline fold. So when the beds are downfolded into a trough like form, then it is called as a syncline fold. The two limbs in the syncline fold, they dip towards each other. You can see here the two limbs, they are dipping towards the axial plane. Okay, and the word syncline is again from a Greek word. The meaning is together inclined. So towards each other the limbs will dip. So in the syncline fold, if you see, the younger bed will be at the center and older bed will be away from the center, that is inside. Okay, younger bed will be outside and the older bed will be outside. Okay, so that is a syncline, towards each other. So this is one example, field photo. Then this is the classification based on the nature of bending, anticline and syncline. Next classification is based on the position of axial plane and the limbs. So we know what is axial plane, the plane which divides the fold into two equal halves, and the limbs are the sides of the fold. So based on that, there are different types of folds. The first one is symmetric fold or symmetrical fold. So symmetrical fold is one where the axial plane is essentially vertical. You can see here the axial plane is vertical and the two limbs, they dip away from each other at the same angle. Okay, but in the opposite direction. So the angle of the limbs, okay, that is same but in opposite direction. So that is called as the symmetrical fold. Okay, the next type of fold is, so this is the axial plane. Okay, then next is asymmetric fold. So what is asymmetric fold? Here the axial plane is inclined and the two limbs, they dip at unequal angle, whereas in symmetric fold the two limbs, they were dipping at the same angle, but here the angle is not same. Here you can see this is the axial plane, this is the axial plane, and here you can see this angle is different and this angle is different. Okay, so they dip at unequal angles, that is called as the asymmetric fold. Then next is overturned fold. Overturned, so the in overturned fold or overfold, the axial plane is inclined and the both the limbs, they dip in the same direction at different angle. So both the limbs, they dip in the same direction. You can see this is one limb, this is the other limb, so these are dipping in the same direction. So that is because this limb has overturned. Okay, so the overturned or inverted or the reversed limb is one that has been rotated through more than 90 degree to attain this present dipping or present attitude of the limb. So the normal limb is one that is right side up, okay, and this is the overturned limb. So what is an overturned fold? Wherein the two limbs, okay, the axial plane is inclined and both the limbs they dip in the same direction at different angle. The angle will be different but they dip in the same direction. That is called as the overturned fold. Then next is recumbent fold. Recumbent is the fold, okay, the folding is so that so intense that both the limbs they become almost horizontal. So the fold in which both the limbs they are almost horizontal. You can see the limbs are almost horizontal. Then it is called as the recumbent fold. So the axial plane is also horizontal and the limbs are also horizontal. In such fold the limb they lie vertically above each other. Then next type is an isoclinal fold. So here the axial plane are parallel and the limbs are almost horizontal. Isoclinal. Iso is same and clinal is inclination. So it is a Greek word meaning equally inclined. So in these folds the limbs are dipping in the same direction at equal angle. That is important here. The angle is equal. Okay, so the axial plane they are essentially parallel and they are of three types. One is vertical isoclinal, inclined isoclinal and recumbent isoclinal. So in vertical isoclinal axial plane is vertical, axial plane is vertical. In inclined isoclinal axial plane is inclined, and in recumbent isoclinal the axial plane is horizontal. So that is called as the isoclinal. Angle is same. That is important. So this is the classification based on the position of axial plane and the limbs. Then the next, here again you can see there is a fold. This is a satellite image, okay, which is a big fold. Here you can see these are mountain ranges which have been formed because of the folding of rocks. Okay, so this is the folded rock. So here in this image you can see all the folds at one stretch. Anticline, syncline, okay, then oppositely inclined, overturned, okay. So these are the different types of folds: symmetric, asymmetric and overturned fold. Then next classification is based on the intensity of deformation. The intensity of deformation. So that is very easy. That is open and closed fold. So what is open fold? During folding the beds may get compressed slightly due to lesser extent, okay. Then what happens to the rock? The rock layer they may not undergo any variation in the thickness. So such type of folds which are of same thickness, okay, same thickness, then it is called as the open fold. Whereas in closed fold what happens? It is the fold which is caused by severe compression, okay, and here the beds they become thinner at the limbs and thicker at the crest and trough. That is called as the closed fold, okay, the fold in which the limbs are thin and the crest and troughs are thick. That is called as the closed fold. And in open fold the thickness remains the same, okay, there is no variation in the thickness, then it is an open fold. Then next classification is based on the attitude of the fold axis. Attitude is the dip and strike is called as the attitude. So this we have already discussed, that is plunging and non-plunging fold. This is based on the fold axis. So what is fold axis? The line of maximum curvature in the fold, that is called as the fold axis. So there are two types, plunging and non-plunging. So the axis of a fold may be horizontal or it may be inclined. So the fold which is having inclined axis, here you can see the fold is having inclined fold axis, and the angle of inclination of the axis with the horizontal plane, that angle is called as the plunge, angle of plunge or plunge angle. So the folds whose axes are horizontal, they are called as non-plunging fold. So here the fold axis is horizontal, so it is a non-plunging fold, and this is the plunging fold wherein the fold axis is inclined. You can see here this is a fold, okay, and this is the fold axis which is inclined. It is going down, it is inclined, so that is called as the plunge of the fold. Here you can see the rocks are folded like this, and this is becoming inclined, the fold axis is inclined, then such folds are called as plunging fold. So this is the classification based on the attitude of fold axis, that is the inclination of the fold axis. Then there are some special types of folds, okay. In that, the first one is monocline fold. Monocline, mono is one, okay, inclined, only one inclination you can see. So the beds are relatively flat, but they appear to have bent locally to exhibit an abrupt steep inclination, and this type of folds is formed by the vertical movement. So here you can see there is a fault at the bottom. Because of this fault, the beds have moved down and these are moved up, and because of this part shows some bend, and on both the side of the bend the strata are nearly horizontal, okay. So such type of fold is called as the monocline, okay. So these rocks are ductile, these are brittle, so they have undergone a crack, they have resulted into brittle deformation, and because these rocks are ductile, they have not undergone breaking, they have just bent. So that is the reason of forming the monocline fold. Otherwise this would have been a fault, but because these rocks are ductile at the top, they are having, or they are showing the bends. So such folds are called as monocline folds. Then one more type is structural terrace. So here the dipping strata, so here you can see the rocks are dipping, okay, and this dipping rocks, they become suddenly horizontal at a particular spot, and then again they continue to follow their original dip. So such type of folds are called as the structural terrace. Then the next type is drag fold. Drag fold you can see here. So these are the minor folds. You can see here the folded rocks, okay. So these rocks are different, these rocks are different, and in between a layer that has undergone folding. So this type of folds are minor folds which are developed within the weaker beds which are enclosed between the two strong beds, okay. So these folds, they are produced due to dragging effect, so they are called as drag fold. So when a competent or the strong bed, it slide past an incompetent or a weak bed, then such type of folds can be seen. So the example for incompetent or weak rock, that may be a shale, okay, and the competent rock may be quartzite or sandstone, which is a strong rock. and this shale is a weak rock. So when there is a tectonic forces acting on it, the weaker rock that undergoes folding. So that is called as the drag fold. So in this image also you can see only the limbs. On the limbs you can see the weaker rock that has undergone a dragging effect. So such type of minor folds are called as drag folds. So here you can see the ductile deformation. Okay. The next type is chevron fold. Chevron is the fold which are usually the folds will have the rounded crest and trough, but here in the chevron fold the crest and the troughs you can see they are pointed. You can see here in the image, right? So here also you can see the crest and trough of the fold are pointed. Okay, they are sharp and they have the straight or nearly straight limbs. So such folds are called as chevron folds. So here again example for chevron fold wherein the crest and troughs are pointed, sharp. Then the next is anticlinorium and synclinorium. So what is an anticline fold? We have discussed anticline and syncline. So this is an anticline, okay, and this anticline has again thrown into minor folds. So that is called as anticlinorium. So these are the large anticlines and synclines which are further thrown into smaller folds. So these folds they are very large in their extent, and locally they are wrapped into numerous small scale folds of various types. So that is called as the anticlinorium and synclinorium. So if it is a syncline, here you can see there is a syncline which is again thrown into smaller folds. So that is a synclinorium. So geosyncline is one more word which is a large depression which is running hundreds of miles long and tens of miles wide, in which many thousands or tens of thousands of feet sediments they accumulate. So such big depressions are also present, and those are called as the anticlinorium and synclinorium. So here also you can see, okay, so all these folds we have to describe with the figure if it is asked in exam. The next is fan fold. So fan, usually in an anticline fold the two limbs they dip away from each other, but here they are dipping towards each other, and in syncline they dip away from each other. So this is because of the fan structure. Fan fold is one in which both the limbs they are overturned, because the limbs are overturned. So in an anticline fan fold the two limbs they dip towards each other, and in syncline fan fold the two limbs they dip away from each other. You can see here in an anticline fan fold the two limbs they dip towards each other, whereas in syncline fold what happens, the two limbs they dip away from each other. That is a syncline fan fold. Then similarly there is one more fold which is like box, okay, box fold, wherein it has a flat crust and trough like a box. So that is a box fold. Then next is one more special type of fold, that is dome and basin. So here the dome is a special type of anticline in which the beds they dip away from each other from a central point. So from a center point all the beds they dip away from each other in all the direction, and whereas reverse in the basin what happens, a depression is formed wherein all the beds they dip towards the center point. That is called as a basin, is a type of syncline in which the beds they dip towards the center point, okay, from all the direction. So that is the dome and basin. So these are all the different types of folds, okay, wherein you can see this is a syncline, these are minor folds, folded rocks, okay, these are again from Dharwad, okay, that is banded iron formations, wherein you can see the bends, the folds in the rock, right? So here is the recumbent fold, okay, there are two recumbent folds. So these type of folded rocks you can see, this is big anticline fold, folded rock again. So this is from Rajasthan. So this is a fold from Sinteri rocks, which is near Dandeli. So what are the causes of folding? So there are two causes, one is tectonic and other one is non-tectonic. So tectonic causes are produced due to the forces which are operating within the earth's crust, such as the compressional forces, okay, which are acting on the rock and they cause the shrinkage or convergence. So that results into folding. Then the igneous intrusions or the salt intrusions which cause the upliftment of sedimentary strata, that also results into the folded rocks. Then non-tectonic causes includes the landslides or differential compaction or subsidence, land subsidence, suddenly the land will sink down, okay, that is, these are the non-tectonic causes. Then the last concept which is very important, that is engineering consideration. So as a civil engineer, why these folds are important? So this has a very cautious or while dealing with the folded rock, because whenever the folds are disturbed, what happens, they release the stored energy in them. So if there are folded rocks already existing and if you disturb them, then they may release the energy which is stored in them and they may damage the site in various ways. So the folded rocks, they are highly fractured, particularly along the axial plane, axial part. So these fractures, they not only make the rock weak, but it acts as a channel or the ways, okay, for the water percolation through them. So because of this, the construction of tunnel or a dam site or a reservoir site, or even when you construct the highways, they cause the problem, okay, because the water may percolate through those, okay. So the various effects because of the folded rocks, they are like the folded rocks are under considerable strain, and because of that excavation through them may be accomplished by a slip and the rock burst. So rock may undergo bursting, okay, so that is because they release the stored energy in them. Then they are generally shattered or weak, and because of that only they have undergone folding. So because of this, they are unsafe to be trusted as a roof or floors for the tunnel or the foundation of dam, okay, they become weaker rocks. And the fractured rocks, they are highly permeable. While excavating tunnel through such regions, the groundwater, what happens, it may rush into the excavation. So similarly in dam construction also, heavy leakage because of the folded structure is possible. So the folded rocks, they offer a great prospect for groundwater, especially the syncline folds. What happens in syncline? All the water will come and accumulate here, so it becomes a good reservoir for water also, okay. Then anticline fold, they provide a good prospect for storage of petroleum. So in anticline fold, usually we get the petroleum deposits. So this is the engineering importance of the folds. So this concept is very, very important from engineering point of view when we deal with any type of construction like dam, tunnel, highways. Okay, so this question is important from exam point of view. Here we have to study the parts of fold, the types of folds, the causes of folds, and the engineering consideration of folds. So all these are important concepts on which the questions are asked. Thank you.